Hello everyone. Let's say you are doing some quantum computations, and while carrying out such a difficult task, your computer fails and returns the error that there is no memory left. Now, how can you get out of this situation and perform the computation task? Well, imagine this. What if you receive the computation power of a few more computers? In this case, you will be able to address the computation problem. Definitely yes, right? But buying multiple computers is not a feasible option because that would require a lot of unnecessary funds, right? This is the problem AWS solves. It provides computing and many other services over the internet to help you solve problems you want to solve. And EC2 is one of those services, which is something you can relate to with computing. On that note, hello everyone, welcome to the video on AWS EC2 tutorial by Intellipaat. In this comprehensive tutorial, we are going to cover AWS EC2 inside out, starting from getting introduced to it to building an EC2 instance. So watch this video until the end and don't forget to enable both the subscribe button and bell icon for Intellipaat YouTube channel.
Welcome everyone. In this video, we'll talk about Amazon Elastic Compute Cloud, the most popular service. Amazon Elastic Compute Cloud, better known as EC2, a central part of the AWS ecosystem and a key service you will need to understand. EC2 provides resizable compute capacity in the cloud. It is designed to make web scalable. Without this, you will not be able to perform many operations. It makes web scale cloud computing easier for developers by offering virtual servers known as instances. With EC2, you have complete control over your virtual computing environment. This means you can choose the configurations of your instances, select the best instances type for your application, and scale up or down as per requirement change. Think of EC2 instances like renting a powerful computer from Amazon. You can install your applications, configure the settings, and run them as just you would on a machine in your own data center, but with added benefits of AWS infrastructure. The true power of EC2 lies in its elasticity. You can start with a single instance and scale out to 1,000 using auto-scaling and elastic load balancing. When preparing for the solutions, you should familiarize yourself with the various instance types. Security, networking, and storage are also an integral part of EC2. AWS provides various tools to manage, like security groups for firewalls, elastic IP addresses, and integration with EBS for storage. To wrap up, EC2 is scalable, secure, and high-performance environment, is why it's staple in cloud computing and a vital component of any toolkit. Now, what is elasticity here? Imagine a world where cloud computing resources expand and contract perfectly with the ebb and follow your business needs. Elasticity is the hallmark of cloud computing, empowering systems to dynamically adjust to changing workloads. It's like having a balloon that inflates or deflates based on the air, or in this case, data flowing through it. Autoscaling is where magic happens. With the power to automatically adjust resources, it ensures that you have what you need, when you need it, maintaining efficiency and performance without manual intervention. And let's talk about balance. Elastic load balancing spreads demand so smoothly across your resources that your users experience consistent, uninterrupted access even during unexpected surges. Take Amazon S3, our object storage service that scales to store and retrieve any amount of data from anywhere, or Amazon RDS in that case, which makes database scaling a breeze. These services personify elasticity in AWS. This flexibility means cost savings as you only pay for what you use and peace of mind as you trust AWS to respond to your infrastructure needs automatically. Now let's talk about next. In this you can see the users are sending a request to the web, and that users, let's say there are 3 users, they are sending the same request to the web server, and without elasticity I have a fixed number of servers at the backend. Hence, increase or decrease in the users won't impact the number of servers, making it a bit of cost expensive for me. Whether in its case of elasticity, if you see, if I have 3 users, my AWS will automatically scale this to the required servers. 3 users, 3 servers at the backend. And for example, when the load is decreased, 1 user disconnects. Now 2 users, 2 servers. So this scaling from 3 to 2 automatically happens without any manual intervention. Now, when we talk about some components of this EC2 service, let's start with the instances. Think of instances as the heart of EC2. Virtual servers in the cloud. These can be tailored with varying configurations and operating systems to match your specific application needs. Moving on to AMIs, the Amazon Machine Image. These are like the DNA of your instances. These are pre-configured templates that include everything needed to boot up your server, from the operating system to applications. AMIs streamline the deployment of your instances. Next, we have the EBS, or the Elastic Block Store. These are the persistent storage volumes for your instances, allowing you to store data independently of the life of an instance. Now, what are instance types? AWS provides a variety of instance types to optimize for different use cases, whether you need more compute power, more memory, or other resources. That's the instance type every scenario. Instance types mainly configure the amount of RAM and the amount of processors that you need, and they also have different categories depending on the performance, whether you need a high throughput, high input output performance, or more compute optimization. And finally, the load balancing. This component is critical for maintaining applications performance and availability, distributing incoming traffic across multiple instances. We cannot forget key pairs. These are part of security mechanism of your instance. This enables secure SSH access to your instance. Key pairs are just like a password, but these are stored in a file, which is very highly encrypted and cannot be shared to any other person unless and until you want to authorize that person to that instance. Talking about instance types. Selecting the right instance type is like choosing the right type of engine for your car. It needs to be fit for the purpose and efficient. You cannot choose a 1000cc engine for a off-roading car. Now, today we are exploring the various EC2 instance types. Let's start with the compute optimized instance. These are the sprinters of the instance family, designed for applications that benefit from high performance processors. Up next are storage optimized. These are the cargo trucks, ideal for workloads that require high and sequential read and write access to the large data sets on a local storage. So compute optimized mainly focuses on high performance, and storage optimized for high read and write input output process. Then we have memory optimized. These memory optimized are for applications that process large data sets in the memory. Means storage optimized means where it processes at the back end where they are stored, whereas memory optimized focus on querying that data in the RAM itself. And finally, accelerated computing instances. These instances are like the turbo boost, using hardware accelerators or coprocessors to perform functions such as a floating point number calculation, graphic processing, or data pattern matching more efficiently than software running on CPUs. Now, understanding these instance types and their use cases will allow you to make informed decisions about balancing performance and cost. I hope instance types are clear now. Now, what is an AMI, or an Amazon Machine Image? An AMI is more than just an image. It's a template packed with all the ingredients you need to launch an instance. Think of it as your starting point, a snapshot from which entire servers can be replicated. With AMI, deployment becomes a breeze. They hold the configurations, the software, and even the permissions needed to spring up a virtual server with a single command. Each AMI is composed of several key elements. We have the Elastic Block Store, or the EBS snapshot, capturing the data state of our server. Then there's the block device mapping, detailing where to store the data and what to store at that location. Launch permissions are equally vital, determining who can use the AMI to launch instances. It's about control and sharing, keeping your cloud environment secure and collaborative. Within a virtual private cloud, AMIs are like a library of possibilities. Launch 1, 10, or 1000 instances, each an exact replica or a new variation based on the original template. Now, we will see how to create, manage, and leverage AMIs in our hands-ons. Now, what is the AMI lifecycle? The lifecycle begins with create. You start by creating an EBS snapshot. This snapshot captures the state of your volume at a point in time where you can use the baseline for a new AMI. Once the snapshot is ready, we register it. Registration makes the snapshot an AMI, giving you the ability to launch instances from it. Now, launching is where the AMI springs to life. From it, you can create a new instance or multiple instances, each an exact replica of an AMI's stored configuration. You might want to operate in different region or have redundancy. The copy allows you to replicate your AMI from one region to another, ensuring your application can be globally distributed or backed up. So we start by creating an AMI, which also creates a EBS snapshot, which can be registered as an AMI now. In case you want to remove that AMI from your system or the AWS console, you can just select your AMI and deregister. When an AMI is no longer needed, you can deregister it, and this doesn't delete the AMI, but it doesn't remove from the list of available AMIs. Now each step in AMI lifecycle is an opportunity to manage, deploy and scale your applications efficiently. So I hope the EC2 service is clear to you. It provides you instances, storage and load balancing. You can use multiple instance types. We have discussed about instance types, key pairs, AMIs, EBS. In this hands-on, we are going to perform EC2 instance creation and connection using two methods. We'll use the instance connect option on the browser and we'll try to connect using the SSH command. To do this, I have logged into my AWS management console. Inside that, I'll go ahead and open EC2 service. So you can search it on the search option on the top. So once you open this service, you will see on the left instances. Select that and now click on launch instances on the top right. Here, provide a name to your EC2 instance. For my case, it is Intellipaat _ EC2. Now you can choose any of the AMIs. For Linux based, you can either choose Amazon Linux or you can use Ubuntu. So in this case, I'll go with the Amazon Linux, which is an indigenous AMI of AWS. Once I've selected, you can select a instance type. I'll keep it to default t2.micro as it is a free tier eligible instance type. Go ahead and now you need a key pair. So if you already have a key pair, you can select any key pairs from the list. But if you are new on this console or if you are working in a new region, you need to create a new key pair. Provide a key pair name and then just click on create key pair. Now this key pair is automatically downloaded on your system. Go ahead and select the VPC settings. As of now, the settings of VPC are default. Now you can also select an existing security group or create a new one. So as of now, I am creating a new security group which only allows SSH traffic. After that, make sure you have the sufficient amount of your EBS volume. That is 8 GB is a default storage. Once done, under the number of instances, you can choose the number of instances or the replicas or copies of these configuration you want to launch. As of now, we are only going to launch one instance. Once you have reviewed everything, click on launch instance. So this launch instance would take around 4 to 5 seconds to complete. And now you can see the initiate has been successfully started. So once you see here, my instance state is pending. Now this takes around 10 to 20 seconds to complete and get into the running state, by which we'll be able to connect to this resource. So let's give it a refresh and now you can see our instance is in the running state. Now if you want to go ahead and connect to this instance, we can follow two methods. The first one is directly connecting to the browser method. To do that, click on connect on the top. Select your EC2 instance connect option. Make sure the username is EC2-user and click on connect. This will open a new tab under which your instance connection starts. You can see the instance has been successfully connected, and now you can just go ahead and perform any basic command and work with this instance from here. So our instance is already updated and we have performed the yum update command. So this is one of the methods to connect to your EC2 instance. The other method to connect is using the SSH from your command prompt. So I'll copy the public IP address of this instance under details. Then open your terminal or command prompt as per your choice. Here you can see I'm on the Delete section. I'll just move to the downloads where we have our key pair stored. So the key pair that we downloaded, it has to be stored, and make sure you navigate to that directory before executing the SSH command. So my key pair is stored in the downloads section. So that is here. Now write the command SSH space -i space the key pair name. So the key pair that we have created is shiv_intellipaat.pem. So this is the key pair that I'm using. You can use your key pair name here. After that, provide the username of your EC2 instance. And for Amazon Linux, it remains as EC2-user. If you have created an Ubuntu based Linux system, the username here would be Ubuntu. Then provide @ and paste your public IP. Once done, hit enter. And once this prompt comes that are you sure you want to continue connecting, just provide yes. Now you can see we have connected to the instance from our command prompt. And to verify whether it's the same instance, let's create a new file, intellipaat.com. So you can verify that there is a file intellipaat.com here. Let's also switch back and see here with the ls command. You will find the same file here. So this makes sure that we have connected to the same instance. So that's how you can launch a basic instance with the Linux AMI and also connect it using multiple methods. In this video, we are going to go ahead and perform an EC2 instance launch for Windows instance type. That is, our Windows AMI will be used, and we'll see how to connect to a Windows instance. So to do that, I have logged into my AWS console and I'm ready to launch a new instance. So click on Launch Instances. Now provide a name to the instance. So in this case, I'm providing Intellipaat_Windows. Then select your Windows AMI. Now you can configure any of the older or the newer AMI versions as per your choice. So I'm going with the default Windows Server 22 base. Choose an instance type. We'll keep the t2.micro as it is a free-to-air eligible. And then go ahead and select a key pair. If you do not have a key pair as yet, make sure you are creating a new key pair by providing a name. For us, we do have the key pair and we'll go ahead and select the key pair. Next is going ahead and checking the network settings. This is our default VPC that has been selected. Auto assign public IP is enabled. If you want to change the VPC, you can click on Edit and select Other VPCs. Now the security group is created with allowing the RDP port only. That means you will only be able to connect to the instance and not perform any other communication on any other ports. That's all what we want right now. After that, check the EBS configurations. It is 30 GB by default for any EC2 instance which is using an AMI of Windows. After that, make sure the number of instances is 1 and now launch the instance. So the launch initiation has started. So you can see successfully initiated launch of instance with the instance ID. Now to connect to a Windows instance, you require the RDP protocol or the RDP client to connect to it. For that, we will be using our Windows RDP client. So let's wait for the instance to be in the running state first. Let me refresh. This could take up to 10 to 20 seconds to complete. So you can now see approx 10-12 seconds that it took to get into the running state. The larger the instance type, the faster the instance gets booted up. Now to connect to this instance, you need a username, a password and the key file. So I'll click on connect and here we'll choose the RDP client option. Now connect using RDP client. You can download the remote desktop file from this section. Now this file has been stored in my Windows. This is the public DNS, the username of this will remain administrator. Now you need a password. So click on get password and it will take at least 4 minutes before you can retrieve the password. So now I'll be just pausing the video until this section is enabled. This could take up to 4 to 5 minutes to get ready. So now you can see that I have the option of get Windows password. To decrypt the password, you are required to upload your private key file. So to do that, I'll go to my downloads and I'll select my key pair. Once the key pair has been loaded, click on decrypt password. And now this is a password that you're going to use to connect to the instance. Copy this password and launch this Windows RDP file. Click on connect. And now just paste the password on the available field. Press OK and click on yes in the identity of the remote cannot be verified pop-up. Now you can see that my instance has been successfully connected. It is getting me logged in using the username and password administrator and the password that we just used. So now you can see we have connected to our T2.micro Windows instance type. Now you might face a bit of lag when you're connecting it for the first time because it is getting its all services and other processes up and running. So now you can see that we have connected to an Amazon Web Services EC2 instance launch. So I hope everyone is clear how to go ahead and create a Windows instance and connect it using the RDP client. We are going to go ahead and create an EFS file system and mount it to two different EC2 instances. To do that, let's quickly launch EC2 instances. I'll name them EFS_demo. You can choose any of the file systems. I'm choosing Ubuntu because Ubuntu requires some additional installations to configure EFS to be mounted, whereas Amazon Linux already has those compatibility softwares. So hence, to know that, I'm using this. Choose a key pair. We do not have a key pair here. Let me create new one. I'll save it in my system. Now I'll choose an existing security group for now, for example, the default one, and I'll launch two similar instances. Okay, and click on launch. So these two instances will be launched in a while. Meanwhile, let's go ahead and configure a EFS file system. So I've opened the EFS service. You can search in the search bar as well. Click on create file system and provide a name. So I'll name it Intellipaat shares and create. So this file system has been created, and if you get inside, there will be a section of mount points under network. So these mount targets have to be ready. So it will take few seconds to get ready so that we are able to mount it. So until and unless they are ready, we will not be able to use them. Meanwhile, let's go back to the instances and just search for running instances. Let's connect to them one by one and configure them to be with all the specific permissions they need. So we are connected to the instances. Just take the root access so that we can install stuff. Provide apt-get update, and similarly here. Okay. Done. Now we are going to install a package that is called as nfs-common, and this is the package that will help you mount your EFS file system. So I'm installing this in both of the instances. Done. Yes. Now we also need a mount point, so I'll create a directory EFS. You can see. Similarly, here we'll create a directory EFS2. Okay. So both the instances are now fine. Let's see whether our mount targets are ready. Let's refresh. Yes, they are in the available state. So I'll close this, click on attach, and just copy the NFS client option. Just copy this command, come back to the instance and paste it. Now the last name here is your mount point. So for this instance it is EFS2. So I'll just add a 2, hit enter. Similarly, I'll come back here, paste the command, and here I don't need a 2 or anything. So because the name itself is EFS, so hit enter. Now in both the instances you can see it has been successfully done. Now let's just try whether it is sharing the files or not. So I'll just get inside the directory, empty here and empty here. Now I'll create, let's say using the nano command, I'll say Intellipaat.txt EFS successful is my message. Save and exit. So I have a file named Intellipaat.txt in my first instance. In the second instance, if I do ls, there is a Intellipaat.txt. What if I see the content inside this using the cat command? We'll find EFS successful as the content. So this means my EFS is sharing files between both the instances in real time. If I just do any file name, for example demo, the moment I execute it here, it will be available in the other instance. So that's how EFS works, and that's how easy it is to configure an EFS to multiple systems. So autoscaling is all about managing application availability and optimizing cost. It lets you set up the scaling policies that automatically adjust the number of instances you're using, whether it's a spike in your traffic or a lull. Auto-scaling adjusts the instances count to meet the demand without manual intervention. You can implement dynamic scaling policies that respond to real-time metrics such as CPU utilization or network input-output. For example, you can have a policy that adds more instances when CPU usage goes above 70%. Alternatively, predictive scaling policies analyze historical load patterns and schedule the right number of instances in anticipation of future demands. The beauty of autoscaling is its ability to help you ensure that your application can handle the workload during demand surges, like holiday sales, while also conserving the resources during quieter times. It's a balance between performance and efficiency tailored to your application's need. Now, for serving this purpose, we have the automatic auto-scaling of Amazon. Now, what is the need? So as we discussed, it is designed to ensure that your application remains highly available and performs optimally. It does this by automatically adjusting compute capacity to match the flow of traffic to your application. Imagine your application client needs the internet. Now, representing end users from around the globe, they expect fast, reliable access to your applications at any time of the day. The load balancer acts as a traffic director, ensuring requests are distributed evenly across your servers. But what happens when traffic spikes or drops? This is where autoscaling comes into play. It allows you to scale up by adding more power to your existing servers, or scale out by adding more servers to handle the load. Similarly, when demand drops, autoscaling can reduce capacity to save on cost without sacrificing performance. Autoscaling provides a responsive and cost-effective way to handle traffic, ensuring that resources are there when you need them and scale back when you don't. With EC2 autoscaling, you can trust your application infrastructure is agile as your business needs to be. Now, what are some autoscaling terms? We'll start with scale in. This is the process of removing instances to reduce capacity in response to the decreased demand. It is like sending some workers home when there is less work, ensuring you are not overstaffed. Scale up means increasing the compute capacity within existing instances. Think of it as giving workers more powerful tools to handle their tasks more efficiently. Now, scale out refers to adding more instances to handle an increased load. It is similar to hiring more workers during peak times. Now, scale in means removing the number of instances. and scale out means adding number of instances. When we talk about scale up, we are increasing the computing power of that single instance, means moving it from t2.micro to t2.large. And similarly, scale down is when we involve the decreasing the computing power or capacity of the instance. It's like downgrading the tools of your workers, which can be appropriate when demand is consistently low. So these are the major terms that you will deal with. Then what are autoscaling components? Starting with autoscaling groups, these collections of EC2 instances are treated as a logical grouping of purposes of scaling and management. When conditions demand, this group can automatically adjust adding or removing instances based on predefined criteria. Health checks are next. They are vital to autoscaling because they ensure that the group only uses healthy instances. They monitor the health of each instance within the group, replacing any that are unhealthy to remain your application's optimal performance and availability. Lastly, we have the scaling policies. These are the rules that define when, how, and in what quantity your autoscaling group should scale out or scale in. They can be based on a variety of metrics like CPU utilization, network traffic, or even a custom metric specific to your application. In combination, these components form a dynamic system that can respond in real time to the needs of your application, ensuring that it remains responsive and cost effective. Next, we'll talk about the benefits. So, first is the better fault tolerance. Autoscaling isn't just about handling load efficiently, it's also about maintaining the health of your fleet instances. It monitors your instances and automatically replaces any that becomes unhealthy, minimizing the risk of downtime and maintaining your application's robustness. Next up is better availability. Autoscaling ensures that your application has enough capacity to handle incoming traffic. Now, these can be done at any time automatically. So by maintaining the optimal number of active instances, it guarantees that your application is always available to your users regardless of any unpredictable surges in the traffic. EC2 autoscaling also has better cost management by adjusting the capacity based on demand autoscaling. Now you won't pay for idle resources as autoscaling will scale down the number of instances during low traffic periods and scale up only when needed, ensuring you pay for what you actually use. Then we have launch templates, critical components. Launch templates store instance launch parameters, which serve as a blueprint for deploying EC2 instances. They encapsulate everything from the instance type to the key pair that you use, security groups, and even the storage configuration. By using these templates, you ensure that every instance launched is consistent with the same specifications, eliminating variability and manual configuration errors. Furthermore, launch templates are integral to autoscaling as they ensure that all instances in the scaling group conform to defined configuration. When autoscaling needs to be adding or removing instances based on demand, it refers to the launch template to spin up the new instances with exact same setup, preserving the uniformity of your fleet. Launch templates are also excelling in ability to provide uniform configurations for on-demand or on-spot instance fleets. Whether you are leveraging spot instances for cost saving or on-demand instances for healthy reliability. Now, launch templates maintain the same instance configuration across the board. Also, when we talk about launch templates, the various launch templates are there. They support template versions, which means you can roll out gradual updates to different groups over time. This staged approach ensures that changes are manageable and that each update can be tested before wider deployment. Dealing with the dependencies can be complex. AWS simplifies this. Launch templates handle dependencies to ensure that instances launch without errors. It is all about removing the guesswork and minimizing the risk of misconfiguration. Finally, compliance management is a significant concern in cloud architecture. Launch templates help by enforcing baseline configuration such as security groups and IAM roles, which are critical for maintaining security and also control policies. Then we talk about launch configurations. Now, it is not much recommended by AWS themselves to use launch configurations. Only launch templates are something that they recommend. Now, launch configurations are also the templates that you use to create new EC2 instances. They define the instance configuration like the ID of the AMI, the instance type, key pair, and security groups. The critical point to note is that launch configurations are exclusively for auto-scaling, unlike launch templates, which offer broader functionality. They can also be used to launch individual instances, but launch configurations are only for the auto-scaling groups. Also, it is important to understand that you can maintain only one version of a launch configuration, in contrast of launch templates, which allow multiple versions, providing greater flexibility to managing different instance configurations and requirements. Lastly, launch configurations do not support some of the newer features like capacity replacement or instance waiting that can launch templates be doing now. These advanced features in templates enable more sophisticated scaling strategies than configurations. So also, when initially launching configurations were standard methods for defining instance configuration in auto-scaling groups. It is important to note that they are now a legacy concept. AWS has shifted towards launch templates, which are the current recommended approach. A critical aspect to remember is that once instances are launched from a launch configuration, you cannot modify it. To update an instance configuration, you will need to create a new launch configuration. This immutability means that launch configurations require forethought and planning. However, with the newer launch templates, AWS offers flexibility and options for customization. So now let's talk about autoscaling groups. It is essentially a group of EC2 instances that are managed as a single unit. The key benefit here is that you don't have to individually adjust the number of instances. The group does it for you. So whether you are dealing with a surge in the number of instances or a web traffic, your application can easily be managed with your autoscaling group, ensuring that the number of active instances is automatically adjusted. The group works tirelessly to maintain a desired capacity. This is achieved through predefined scaling policies, which respond to real-time metrics like CPU usage and network traffic. Additionally, health checks are continuously performed to replace any instances that are not functioning as expected, ensuring that all instances are healthy and serving traffic. More than just reacting to failures, autoscaling groups also anticipate and respond to change in demand. They scale out, adding instances when demand spikes, and scale in, removing instances when demand drops. This dynamic resizing is vital for maintaining performance while controlling cost. Autoscaling groups simplify the task of resource management, providing a responsive and cost-effective solution to changing demand and instance health. Now, let's also talk about more stuff. So here we can see scaling policies. These policies enable the group to automatically adjust the number of instances based on CloudWatch metrics. For instance, if CPU usage goes beyond a certain threshold, the group can respond by adding more instances. Another crucial aspect is the enhancement of high availability. Autoscaling groups distribute instances across different AZs, which are isolated locations within the data center region. By doing so, they protect your application from failure of an individual zone. Additionally, these groups continuously perform health checks and replace any instances that are found to be unhealthy. This means that you're always running on reliable resources without any manual intervention. Now, with autoscaling groups, you have a system that not only is reactive to current load, but also proactive in maintaining the health and performance of your application. Going ahead and talking about the best practices. Firstly, security is paramount. Ensuring that your autoscaling setup includes features like SSL, TLS, or encrypted data transmission is crucial. We must protect data in transit just as rigorously as data at rest. Next is integrating VPC endpoints for private connectivity is a smart move. This enables your resources to access autoscaling services privately without using the public internet, enhancing security and reducing exposure. Health checks are again the heartbeat. Utilizing ELB for health checks helps guarantee that only healthy instances are in service. This proactive monitoring ensures that traffic is directed to the best performing resources. Lastly, diversification is key. Use multiple instances types and create autoscaling groups to maintain resilience. The variety helps in cushioning your system against instance-specific issues and keeping your application reliable and robust. So now let's talk about the autoscaling architecture.
Within our VPC, we have set up a secure and isolated environment. As you can see, the VPC spans across availability zones for redundancy and resilience. Now notice how we have multiple auto-scaling groups. These groups automate the scaling of EC2 instances, adapting to load changes to maintain steady, predictable performance. By distributing them across different availability zones, we ensure that the failure of one zone doesn't affect our application's overall uptime. Each autoscaling group manages a collection of EC2 instances with identical configurations, dynamically adjusting the number of instances as traffic patterns fluctuate. Now, this architecture helps you understand how autoscaling groups are attached to different instances and how it can be also across multiple availability zones. So that's all for the video, guys. I hope everyone is clear. We'll meet in the next one and talk about more stuff. Thank you.
Just a quick info, guys. Intellipaat offers an AWS certification course for solutions architect certified by NESCOM, and it aligns with industry standards. Through this course, you can learn all the important concepts of AWS, and upon completion of the course, you will receive a NESCOM certification. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of AWS.